red light button up the top. And this is high level of stress.
Yeah, it definitely says live on YouTube. However, I don't see it on YouTube, but oh no, yeah, it works.
Here we go. Good to go. Hello, everyone, and welcome to the very first episode of the Computer Vision Stack. I'm your host, Anthony Kelly, and I am a principal recruitment consultant at Trust and Soda, who helps companies hire computer vision talent, and I also help computer vision talent with looking for their next role. I am a Meetup founder, podcast host, and I've now recently decided to start this Q&A show called the Computer Vision Stack as a way to give the community an opportunity to ask professionals questions real time about how they are using computer vision in production, and what stack they're using, what ingredients do we have. So, we're talking about algorithms, hardware, software, and anything that's involved into making it to the production environment. And anything after that is what we're going to call our additional and our extra toppings. So today's guest is Alexander Gechis. Alexander is the machine learning team lead at Kopernikus Automotive. Alex, it's great to have you on the show. For those who are interested, we're also going to be recording a podcast later this week. But I suppose to start off, Alex, why don't you introduce yourself?
Hey, thanks for inviting me. So I'm Alex. I work as perception lead at Kopernikus Automotive, and I think I can hear myself quite well. Sorry. Yeah. I work at Kopernikus Automotive since a couple of years. I moved to Germany. So I finished my math degrees in Russia, and 5 years ago I moved to Germany to work in a company on big data. And then a couple of years ago joined the company where I work now with autonomous driving stack. So it's like a brief introduction.
Excellent. So tell us about Kopernikus Automotive. I suppose a little bit more about what you are doing and how you are using technology to solve the mobility challenge of autonomous driving or even autonomous vehicles.
Yeah, so the main product that we do is autonomous valet parking. So what we do is convert cars that are not autonomous driving to autonomous driving cars. Basically, what we do is install sensors, which are primarily cameras in some limited space. And all cars that come to this space can be driven by the external cameras and external computer that is set up in the same location. Like, for instance, the first project that we did was in Ludwigsburg for Porsche, where we equipped with cameras the service facility, and person who work at that place, he can decide if he want to work on some other car. He just press a button on a tablet. The system detects the car on parking lot. The car drives by itself inside the gate and inside service facility, and technically can basically work on it. When he finished, he can press a button and car by itself goes out, find free parking place, and parks there. Another application is autonomous valet parking. We have a project finished in Braunschweig earlier this year, where a person who comes into parking house, he can just again go out of the car, press a button on the phone, and the car goes and find parking place by itself. And when he needs to summon a car, he just press a button and it drives back. The most important part is that the car itself doesn't have any sensors on it. So it doesn't have any cameras, any lidars. We don't require it at all. All perception is done by external cameras. And that's what basically I do. I develop system for perception, system for this part.
Nice. I suppose before we go into it, and the reason why, it's very much different, and this is kind of where the topic for this has come from, is that you're using external cameras, but I suppose camera technology is recently on the up, whereas if you maybe talked 2, 3, 4 years ago, camera technology and autonomous driving, it would have never been possible with just camera technology due to the software and the technology just not being there to make it possible. And now it's almost in a way there's companies running it with lidar, GPS, radar solutions, and then there's other companies who are using cameras and maybe radar. But you guys are using cameras, which is where you're looking at, and you're looking to see the success. So what's the rationale from Kopernikus Automotive to use cameras, and why not use lidar, radar, and GPS?
Well, it's easy. It's price. Let's make the project way cheaper. First, it's price of sensors itself. Cameras actually have one here that we install, like normal cheap cameras that you can use, and then not new. They built some, maybe I don't know, like all time ago. We can use work with any cameras. They're cheap. The price of sensors could be around €100. Price of lidars, of course, is way more expensive. GPS, which give you enough accuracy, is also extremely expensive. And the one that are low accuracy, you probably don't want to use because you want very precisely to park between the cars and don't hit any other vehicles on the place. Another moment about cameras itself, they are can be easily positioned on the ceiling of parking garage or whatever you want to place them. There is a solution for autonomous valet parking from Bosch, and they have very nice videos, and they do extremely good job. I really like their solution. However, you can see that the lidars that they all installed on the ground. It means if you come to existing parking facility, if you come to existing factory where you want to position, you have to put all the cables, a lot amount of cables and a lot of amount of sensors on the floor, which is not always possible. And it also brings sometimes to collisions. If somebody human on the car hits the lidar, then facility should go off, or the lidar should be changed, recalibrated again, new money should be paid. So first, it's easy pay. They're cheaper. Second is that it's way easier and cheaper to install them anywhere. If we don't want to have this facility equipped anymore, we can simply unscrew all the cameras, pack them in the trunk, and go away. And of course, the fact that technology is now, the software is on the way that it can process cameras in a way that gives you the same accuracy for localization as lidars.
Okay, nice. So look, I'm not going to go down my traditional road here of what I would do on a podcast. I'm gonna quite challenge you, Alex. And I suppose one thing I do want to ask on is, when you're looking to train a model based on camera technologies, but you want to run it maybe on like the edge device and in the vehicle to predict or look at red lights, pedestrians, dogs, and other vehicles in front of you. With GDPR, there's obviously a lot of challenges with this. You can't use a person's face, you cannot take that data, and a license plate. So anonymization of these or blurring of them is generally the two most common models that companies are using to actually solve these issues. How do you combat that? Because look, if you want to go with a blurred model, and then you want to run a vehicle, the vehicle will not actually see a person. It will see a blur and say that's a person. But if it sees an actual person, it will not predict it as a person because it's not blurred. And then if you want to go down like the model of using GANs, there are companies out there to build that software that you can use yourself, or to build your own one. Can be quite timely. It can be difficult. And then you've got to really look at, am I cheaper using radar and lidar? Like what do you think about that?
That's a very good question. So first, about the training data itself that is used, we quite advanced in simulation to reality transition when you train on simulation data sets and you go to the reality. Our main data set contains from quite well prepared simulation data. There are techniques that allows you to augment it in a way that then later when you do inference of the models on the real data, you have same level of accuracy and same level of false positive and false negative. So the quality of the model is quite good. So we don't need to blow the image, the data itself on the simulated images. Second, regarding the data where we have to use public data sets, so like data sets get it on the public on some places, we of course have to blow up blue faces. We have to remove number plates. For our models, this data is not essential, and this sometimes is actually good for the model itself. When you have different faces, or if you don't have any face, if you have blurred face, then you have exactly same result. So because you detect person not by his face, by shape, probably by movement. And one of the very good methods is using of guns when you just replace a face or replace a number plate with a different one.
Yeah, that's the most. So it's not the most common, the most expensive, but it is also the most efficient for the longer term of the solution. So kind of taking us into our next one. So look, camera technologies has advanced. We were only talking about it beforehand. That's due to smartphones. I watched The Social Dilemma at the weekend, as I was telling you, and they actually talk about how processing power in mobile phones has increased more than any other technology. And that's mainly down to the fact that people are using their mobile phones so much. As a result, mobile phones are now getting better cameras, and camera technology is getting better. Before we talk about lidar or even go into 5G, what sort of future do you see the camera technology having on the autonomous driving or autonomous mobility industry?
Oh, that's a very open question. Frankly speaking, I don't know. So everything comes, when it comes to production, it always comes to cost. And currently, cameras are one of the cheapest sensors that you can have. Lidars have moving parts, they make noise, they break. There is a company in Bavaria that makes MEMS-based mirrors lidars. So they don't have any movable part, and they aim to make these lidars cheaper. And whoever comes to the cheapest place, he will win. If at one moment lidars or radars will be cheaper than a camera, then people will use this. But the receiving information from the world is only part of it. So taking a picture, either it is a point cloud or it is a RGB, it is something else. If it is a thermal camera or maybe a radar, then it's one part. The second part is processing of this data. Even if you have a point cloud by itself, you know there is some object, but you don't know what object it is. Maybe it's some obstacle. Maybe that's a tree that you need to can avoid, but come close by it, or maybe it's a child staying on the ground and you probably should brake and wait when he goes away to have different behavior. To detect this part, very important is the software that you use, machine learning models or any other models that you use underground. And to process it, you need to have very good hardware that process this. So what we see that we currently work with NVIDIA, on NVIDIA hardware, on NVIDIA GPUs. People like Tesla, they make their own inference hardware to be very efficient on the networks that they exactly make. So when this comes to the question, so for me, Moravec paradox, right? When the reasoning, the high-level reasoning is actually computationally very low and could be executed on very low powerful machine. So if you already know where objects are located, to make a decision where to drive, what to do exactly, it's very cheap computationally. But to get information from the world, it's actually the most computationally heavy part. And why it's called paradox, because it's not how human perception works. People think that perception is something simple that we already do, and it's easy to do. And then very hard part is computational, what exactly you need to do given the information that you got from the world. On developing autonomous driving stack, it's a bit different. It's always shifted to perception stack. So yeah, it's hard to say it. For me, I think the main end to the companies will be always price, but first, all the software, all algorithms need to be clearly defined and developed in a way that they assure safety and efficient of driving.
Nice. So, we touched on a topic that I was probably going to mention on later, but if we're talking about running GPUs and NVIDIA and sort of running deep learning algorithms on these edge devices. You mentioned you use NVIDIA and Tesla build their own, but I suppose do you think there's going to be any sort of restrictions by not building your own GPU clusters in a way that when you start looking for a certain amount of processing power, or you want to maybe use a different technology? So like I think it's YOLO. And if you compare it to efficient dev performs a lot better on your own GPU clusters. But better performance on these edge devices means that you can ensure your images are of a constant high quality, and then that the health of the deep learning algorithm is staying efficient, ensuring that you're getting a constant high quality stream of data. Do you think NVIDIA is going to be the way forward, or do you think every company at some stage will probably have to look at their own GPUs if they're looking to take autonomous driving to the streets?
I believe it is the second one, because NVIDIA are all-purpose GPUs where you can run any model that you want, and when you want to make it more efficient, more faster. And there are lots of other companies, lots of new architectures that come to market that works with tensors, and they are way more efficient than the most efficient NVIDIA or any existent available GPUs that you can buy in the market. So I believe that at some moment, people will come to their own architectures, and everyone will use own GPUs. In our case, it's a bit easier because we try to use edge devices, but because we do all autonomous driving on the server and all perception we do on the server, not in the car itself, we just tell the car where to go. We are not limited on the size of our server rack. We can make it a bit bigger, we can make it smaller. We don't care much. We only care about latency. And if we see that we can buy just more expensive or more GPUs from NVIDIA, then we just plug them in and it works fast. Yeah.
Nice. So then, look, I'm going to go back to where I was. Just before I asked about the edge devices and the GPUs, I wanted to ask you about Lidar and Radar. So from the Internet of Things perspective, we know that the 5G is supposed to be a game changer. It's going to be able to connect the right types of devices to practically anything. You're talking a fridge to your alarm clock to your coffee machine, and that's just in your house. You're talking light switches. Basically everything that has a plug or is electric can do that. And then when it comes to autonomous driving, it's looking to have the same impact then as well, to an extent that it can connect the tram to the lights, to the traffic on the streets. Maybe even people, if they've got a bicycle that has some form of chip in it, that they can then start detecting these, and essentially a vehicle will almost look like it will drive on a map as a software instead of driving on an actual street. Do you think 5G has that capability to I suppose trebuchet Lidar and Radar technologies forward to that level, or is that urban legend?
I think that 5G definitely has the capabilities, but I don't believe that it will ever used for this purpose. So 5G is just a connection between any device, vehicle or bicycle, maybe if you prefer some other ways of driving on that transport, and it can update, get information from it. But I don't believe that building some centralized system that can, in our complicated world that can tell which cars where to go, it's impossible. Second, uploading image and LiDAR information to some cloud somewhere outside of the car, then downloaded it. Even with 5G, we need to remember that there's sometimes some latency issues in some specific areas, maybe some big truck car passing by and closing you from the source of 5G connection. So it could be the connection itself could be unstable. And I believe that all perception, independently on what type of sensors you use, should always happen on board, and reasoning on decision of what should be done, it should always happen on board of the car, except for case that we do, because we just extend the place, we drive the cars inside place that we guarantee we know everything about it.
Yeah. I guess when you consider the technologies available, LiDAR and radar are more traditional autonomous driving technologies as opposed to cameras. The reason I say that is if you probably look at Tesla, Audi, BMW, the big companies would have invested a lot of money into it. And look, from my looking at it, it seems as though 80 to 90% of their innovation for autonomous driving is still being led with these technologies. Do you think we'll see the breakthrough in a big company, or do you think that they've probably, like, their investment in these technologies will be huge at this stage, right? Imagine having to go to, like, the chief financial officer and say, yeah, those billions we spent on this technology is no longer going to win us the race. We need to switch to cameras. Could be a case that they just don't want to end up. One, they've run the risk of falling behind, and then two, the other risk is they have to openly almost admit that they've wasted their money on the wrong horse, essentially.
I think we need to define what is winning the race here. If it, in my perspective, if it's delivered in some vehicle that could be L4 or L5 or L3 even autonomously, then on market before other people do it. To do it, you need to be clear that your car can operate in some ODD, some operational design domain, and to be sure that it can handle all the possible situations that can happen here. Say, if you claim that your car drives fully autonomously on Autobahn, then you need to be sure that even whatever happened on the Autobahn, it will always work in this specific area. And I think it makes sense to invest in the different fields, in camera, in LiDAR, in radar, in all possible fields, to get the best from them and to get the car that will be ready to level 3 faster and easier. If at the moment when system will be ready, cameras will give a possibility to do it fully autonomously, then it will be cameras. It always comes to the question of testing. And AI, how many kilometers they claim that they drove already around 1 million kilometers, and it's just 1 or 2 cameras installed on the front of the small device that you install on the windshield. And you can drive quite good with it. I know people who do it, and they're quite efficient. It's just 2 sensors. However, when it comes to very, very specific cases, it will fail and it will not work. And it's the same, unfortunately, for any camera technology that LiDAR or radar, of course, can give you always there is something in front of you, even if it was not recognized by camera. However, working without camera is also impossible in my case, because you don't. I think it is impossible working without any cameras, because you need to have classified information of what is this object about. However, how I said that technology moves, there are lots of depth prediction networks that adopt lots of free space segmentations, a lot of work that shows that using only cameras, we can drive quite well.
Yeah. Do you think it's going to be a case that, autonomous driving vehicles are going to live in harmony with human-driven vehicles? Or do you think it has to be either one or the other? Because look, realistically, if you set up a dummy city and took all the vehicles out tomorrow, you remove one of the biggest threats to actually having an autonomous vehicle, and that's erratic human behavior behind the wheel of a car. What do you think about that? Do you think that's probably would see the best success, or would it even make a difference in the long run?
Well, if we take people's psychology out of equation, like trying to jump in front of the car and saying, "Hey, see it stop," because probably lots of people would like to challenge autonomous driving car, and I think they do. What you see in California, they do a lot of these Waymo cars. But generally, there are models and already test scenarios that shows that a lot of cases when even there is some percentage, not half, just some percentage of autonomous driving car can reduce amount of traffic jams in situations where they do, like the famous models when there are lots of cars evenly distributed on some circle or autobahn, and when one car brakes, then continues, then next brake, then next brake, and even half an hour later, the brakes still exist. If part of these vehicles are replaced with autonomous driving cars, this brake reduces faster than just with human drivers. So I believe that the partial is possible and definitely way to go.
Yeah, no, I've heard a few people say it, all right. But then there's also some people that will never give up driving. It's something that's important to them.
Yeah, people should not. Why? Yeah, people should drive if they want to. I believe that it will be way safer, and even if some part of cars will be autonomous driving cars.
Nice.
Yeah. The only problem that I see with autonomous driving cars, there are lots of discussion whether it will decrease or increase amount of traffic jams on the road, and it's for me a very open question, because once that you have more autonomous driving cars, potentially people will also prefer to use the cars rather than driving in with public transport. So that's the only question where I'm not confident about.
Yeah, that's true. That's true. In terms of safety, so look, road safety is obviously a huge thing worldwide, globally. There's been an increase year on year. Now you can put that increase year on year down to there being an increase in population as well, year on year, and an increase of cars on the roads. So it's not necessarily more accidents per driver on the road, but it's just more accidents every single year. Do you think that if we got an autonomous driving vehicle, the first accident that would result in maybe a death, do you think that would be the end of it? Because even though it's a lot less than what would be if humans were driving the vehicle, a human's expectation is that I'm putting my faith in this technology to take me from A to B safely. And if it doesn't do that, I'm not going to use it. People would trust their own instincts more naturally. That's because we know this, we can understand this. Do you think that would play a big impact, or is there even going to be an opportunity given to allow that?
I believe it will have a very big impact, because people more trust to their senses, even if it is super irrational, because people have kids on the back seat, people have job and maybe slept bad in the night because of some reasons. There are lots of people, any case, it's very hard to focus always constantly 100%. There always are some short time breaks where you have to, people sleep, they get sleepy because they want to drive the last 50 kilometers to the home and finally go to the bed and not make a break just half an hour before the home. So I find it completely irrational, but I think it will have a very big impact. The biggest issue here that I think is that autonomous cars mistake in places where human would never make a mistake. They don't do mistakes in places where human do have mistakes, but at the same time, even though the whole amount of accidents is way lower, these accidents happen in the space where human would never do, like the situation again with Tesla, when there was a big truck that was rotated 90 degrees and it was mirrored. So that person would always see it and he will brake, but for the car it was something strange and he decided not to brake there.
Yeah, well that's a big part of it. I'm just checking, Alex. I don't think we've gone live on YouTube, but I will. Not on YouTube. We are live only on YouTube, and I will have to manually upload it to LinkedIn. But in terms of questions, I don't think we've got any questions coming in. But I think in terms of time, I think I've questioned you out. What do you think?
Yes, we had lots of questions discussed in any case, and I think we can, as we have recording later this week, we can collect some questions that we can tackle during the podcast.
I was thinking the same. So if anybody is watching and you have a question for Alex, drop myself or Alex a mail or a direct message on LinkedIn, and we'll answer your question on the podcast that we're recording together on Friday. But other than that, Alex, thank you for being the first guest on the Computer Vision Stack Q&A show. Great to have you, and have a great week.
It's a pleasure. Thank you.
Cheers. Bye.
Bye. Okay, that was good. Should I disconnect?
Oh yeah, I think that's